Hi, this is Tom, and welcome back to Life 4.0 and our third video in our series on installing solar. We talked in the first two videos about planning and the economics of the project. Now, with the green light for the project, we are moving on to the permitting process, determining the exact design of the structure, and sourcing the materials for the project. So let's dive in first with the permitting process. You'll want to start by visiting your local town office's building department to determine what they need. For instance, one immediate question I had was the setback requirements for a solar array, which I found out was a standard 25 feet, like any other building structure in our town. I positioned the array right up to the setback line to get the most sun exposure on our lot. To apply for the permit, you will need some kind of specifications and design drawings to prove that it is structurally and electrically sound. Hiring an engineer for professional drawings was out of our budget, and after several visits to the town inspector, they accepted my basic computer drawings with some help from the Iron Ridge design assistant. Iron Ridge is a prominent builder of railings and other structural components of solar installations. They have a very handy design tool where you enter the number and type of panels and other parameters you can get from your town, such as wind and snow loads, and it spits out a detailed report with all of the engineering requirements. Importantly, it will tell you the number of concrete piers that need to be set into the ground and their depth and width. In our 28-panel array, we were required to have 10 piers. The Iron Ridge system is a fixed mount system, meaning that you determine the azimuth and tilt of your array, and you are locked into those specs. There are other options where the solar panels either rotate on a single axis or multi-axis, and these are called trackers. And yes, they do improve the solar output by optimizing the angle of the panels to the sun, but they are very expensive and run the risk of mechanical failure. Two reasons I ruled them out of our design. For fixed mount, the Iron Ridge approach has two rows of posts, a short post on the south side and a taller one on the north side. Other fixed mount systems are what is called a single pole mount, one large beefy metal pole, like the diameter of a telephone pole, in the center of the array. These are typically found on large commercial solar farms, and for good reason, as they require special excavation and lifting equipment out of the range for most residential customers. Once I was set with my design, I printed out the Iron Ridge engineering drawings, added a plot plan showing all of the setbacks, and attached this to the permit application. Our town also required a list of materials as part of the application, with special focus on the make and model of the panels, the inverter, and the electrical safety disconnects. If you obtained a high-level quote from the economics spreadsheet we talked about in the previous video, it is now time to refine this quote to determine exactly what you need to order. There's a couple important considerations here. Let's start with the solar panels themselves. I will say that this is no time to order cheap panels off of eBay. With the large investment you're putting into building the array's structure and your own sweat equity, it will be worth it to get a good quality panel that will last 25 years or more. As I mentioned in the first video, we used the Alt-E store in Massachusetts and appreciated their wide choice of panels. I looked closely at the dollars per watt metric and chose the larger 72-cell, 375-watt panels from REC. I really wanted to get the all-black panels for the better look, but they had just sold out of this inventory. Regardless, do your research on the panel manufacturer. A 25-year warranty does no good if the company isn't around then. Next, you'll need to consider optimizers, microinverters, and full inverters. We chose SolarEdge's optimizers paired with their new HD Wave inverter. Inverters used to be a place where you lost a considerable amount of efficiency during the conversion from DC to AC current. With the new inverters at 99% efficiency, this is a moot point. The other option is Enphase's system of microinverters. With two panels plugged into each microinverter, the DC current is converted to AC right at your array. There is no need for a separate large inverter next to your circuit panel like the SolarEdge product or Sunny Boy or Fronius. With N-phase, you simply have AC current running back to your house and into your panel. As I record this, SolarEdge and N-phase are duking it out for market leadership. I think you will be fine with either solution. When I priced it out, SolarEdge's inverter plus optimizers was a bit cheaper than the N-phase microinverters. And SolarEdge seemed to be a more established company, so I went with them. My one regret in sourcing was not getting the higher-end SolarEdge inverter with what they call revenue monitoring. With this setup, the inverter meters the total solar production of your array and reports it to a central industry database for what is called RECs, or Renewable Energy Certificates. These RECs, with one REC being equal to 1 megawatt hour of production, can then be sold on a marketplace, bought typically by utilities that need to hit a certain renewable percentage in their portfolio, and thus give you extra cash in your pocket. I ended up having a separate meter socket wired up for installation by Eversource and having them report these production numbers to the database. It was more paperwork, extra wiring expense, and long delays to get the credits to actually start showing up. The other key safety components are the various disconnect switches, and you want to get input from your town on what is exactly required. Likely, they will require a disconnect switch either at the array or where the wiring enters the house for emergency personnel to use in case of, for example, a fire. They will want to see that the inverter you've chosen has what is called a rapid shutdown switch, which shuts down solar production if grid power to your house is lost, and is meant to protect linemen during outage repairs. Lastly, you will likely need a disconnect switch where the feed enters your circuit panel as another way to shut down the system in an emergency. There are a lot of considerations here, and that is why it is important to be in close contact with your town building department, as well as having a solar supplier that has some experience with the electrical code. Finally, in our permit application, we needed to include an electrical schematic showing how all the components will be connected. Again, a licensed professional can do this for you, but I drew up the components on a PowerPoint document, and that was acceptable to our town. I will include links in the video description to download this document. With the permit submitted, and while I awaited its approval, I took the time to plan out the exact location of the piers. We've got trees still to remove. These two trees here are going to go. I've removed a bunch of trees in this section just to make sure that nothing could be close enough to potentially fall in a windstorm on the array. Not to mention that these big pines, of course, if one of those were to come down, it would be very bad news for the whole project. But there were some dead trees back in here and some small saplings, and I don't want those to grow any larger and potentially have branches come off in a storm, or to have them eventually die and land on the array. So that's the setup we have, and the next step for us is to remove these two trees, additional trees that are shading the array, and then I'm going to start planning out where to locate the piers. You know, I've got the footprint, and I'm going to have 10 piers that are going to be coming in here about 2 feet in, and maybe a foot or so this way and a foot or so inside that way. And so I'm going to have to look and see, and right away I have an issue here because I have an old tree stump here. So I'm probably going to have to move this whole thing 6 feet maybe to the right to avoid having to dig a hole right where an old tree stump is, which would not work at all. So we'll have pairs of piers, 5 pairs all the way down here. I'm not too concerned about digging through here, but I am concerned about that one stump area. And there may be some roots with these other trees here, which is another consideration to do that. And the other thing you want to think about too in a ground mount is anything else you might have in the ground that is a concern when you do your digging. I've already called DigSafe, very easy to do here. I just dial 811 and in a couple days they'll be out and they'll be looking and marking the buried electrical and phone lines and cable and all that. I'm not concerned at all. It's all out on the just adjacent to the road. Runs parallel to the road. I already know where it is, but just to be safe, I'm doing that. I don't anticipate there'll be any issue with any electrical, but we do have a septic system that comes out. The tank is right here, and then the septic field, it goes out this way. I know it's over here, so I'm not an issue when I dig for the piers over here, but you want to think that all through and making sure that you're not going to get yourself into more of a mess with anything that might be in the ground.
before you dig. We'll document this all, but our plan to do the footings is to rent a small excavator. And I know that this is in New England. I know there's going to be rocks around, and we've done our digging projects around our house. We've had issues with small rocks and boulders and stuff like that in the ground. So I'm not going to go with the process of renting a auger. That just won't work with this soil type. So I'm going to use a small excavator and dig the hole. It's going to end up being a much larger hole than I really need for the sonotube, but we'll put the sonotube down, then backfill and locate it that way. And if I run into any rocks, I'm hoping that the excavator will work as far as a tool to get those rocks out. And if any small roots and all that, I can get those out as well. And so I'm just going to try to put bricks down where I think the 10 piers will go, and make sure that that makes sense, whether I have to shift the position horizontally one direction or another for the array in order to make it reliable to dig a 6-foot hole for the piers. Okay, I've done some more measurements and laid out these small pavers here to mark where I'm planning on digging the piers. So I've got those sort of roughly laid out, not too scientific, but they're approximately in the location within a couple inches. And I had to move the whole array over about 2 feet because I've got a stump here, and I kind of split the difference between the pier here and the pier there. So we'll find out once we get the excavator and start digging a hole here, whether we can go down 5.5 feet as required, and similarly here, whether we get into any kind of root issues, whatever. That tree's been out for a couple of years, but it takes a while for the roots to rot. And then down here, I've got the last pier here. It's kind of close to this tree. Hopefully there's no major root issues there. And you can see the way this is laid out is that the piers don't go. This is the end of the new shifted array here. The piers don't go all the way to the end. There's what they call a cantilever. So the horizontal pipes to go along each row of piers to build the grid structure that the panels will eventually go on. And those overhang about a little over 2.5 feet. So that's all part of the design, so that you're kind of spreading out the load. If you have the pier all the way out here, the engineering will require stronger materials to be able to hold that snow load and wind load and all that kind of stuff. So I've got the approximate location. Next step here is I'm going to pull down the mock-up of the pipes and the tape and all that, because I've got 2 trees right behind me here to drop, and those are going to get all in the way of that. So I'm going to pull those trees down. And then I've got to run a stump grinder to grind these stumps up and out of the way. And while I'm at it, I'm probably going to go around the yard and grind up some other stumps that have been sitting there from other projects. So we'll get that all done. I'm still hoping to hear back on the permit, and then we'll go ahead and order all the materials as well.
And around our neighborhood, when it's time for dropping trees, there's always lots of curiosity and a few extra helping hands.
Alright, trees are down, and we've cleaned up the debris and cut up the tree into logs so we can use it for firewood. My next step here is to clear the stumps so that they're not, we've cut them down to as close to the grade as possible with a chainsaw, and now I've got to use this stump grinder that I've rented to grind those stumps down so they're at least at or below grade so I can mow the lawn.
All right, just heard from the town today, and we have our building permit for putting together the solar array, so very excited about that. I had to make one change to the permit when I applied. When I priced out the 3-inch galvanized pipe that is spec'd by Iron Ridge for their ground mount system, I found that, who knew, but 3-inch galvanized rigid pipe is very expensive. It was going to be between $2,500 and $3,000 just for the pipe, the beams and the post pipes to put together the array. So I changed plans, and now we're going to be using pressure treated lumber. So 6x6 posts and twin 2-inch by 10-inch cross beams. So I changed the application to the town, and they accepted that with some slight modifications. And so we're good to go with the permit. Very excited about that. That wraps up this edition of our series on installing solar. Join us next time as we put away the paperwork and spreadsheets and start breaking ground and building upwards. If you enjoyed watching this video, please consider giving us a like, as it really helps others find this kind of content. And lastly, don't forget to subscribe and click on the bell to be notified of our upcoming releases.